All right, today we're doing a deep dive into an unsung hero of global industry,
Mm.
the centrifugal screen. Specifically, the high-precision working screen that you see in really critical filtration.
Yeah, exactly. And our sources for this are coming directly from a major manufacturer, a company called Fine Perforators. They're an Indian exporter, been around since 1969, and they supply these things everywhere: Brazil, Thailand, Iran.
So this is a core piece of the global industrial backbone.
It really is.
Okay, so our mission here is to figure out what this thing actually is, why its precision is so important, and maybe find some surprising places it's used beyond just, sugar.
Well, to start, we have to distinguish between two parts. It's really important. There's the backing screen, which is just for structure, adds stiffness,
Right, just support.
just support. But the real workhorse is the working centrifugal screen. That's the liner that's actually holding the crystals and letting the liquid drain away.
That liquid being the molasses, right?
Mm.
Or what they call massacute when it's all mixed together.
That's the stuff. The working screen is the business end of the whole operation.
When you think of sugar processing, you kind of imagine this rough bulk machinery. But if this screen is separating tiny crystals from that thick syrup, are we talking about microengineering here?
Oh, absolutely. That's exactly what it is. And the benefits are totally tangible. You get better purity in the sugar, your machine cycle times are shorter, and you lose less product.
So that tiny bit of engineering has a direct impact on a refinery's profit.
A huge impact. It's a direct link.
Okay, so if purity is the goal, the holes, the apertures, they must have to be perfectly matched to the crystal size and how thick the massacute is. How tight are the tolerances we're actually talking about?
They are mind-bogglingly tight. The typical slot width is somewhere between 0.04 millimeters and 0.12 millimeters.
Hold on, 0.04 millimeters.
Yep. And just for reference, that is significantly thinner than the average human hair. And that consistency has to be perfect across this huge industrial surface.
Wow. Okay, if the tolerance is that tight, doesn't that make maintenance a complete nightmare? I mean, what materials can even hold up to that?
That's the core challenge, really. And the material choice reflects that balance. Stainless steel is the go-to for durability and, hygiene.
Sure.
But some operators actually prefer brass. It gives a really stable, smooth run, which helps the material flow better.
But it's softer, I'd imagine.
It is, yeah. It needs different cleaning. And then you have copper, but that's more for specific cases, maybe older plants with unique corrosion issues.
With that microscopic slot width, how critical is it that these screens fit perfectly into machines that are made all over the world?
It's everything. I mean, they're supplied, fit ready. They have to match the existing aperture maps for all the big global OEMs.
OEMs like who?
Think BMA in Germany, Western states from the US, Broadbent in the UK, Silver Viable. If a screen doesn't perfectly fit a machine in, say, a Brazilian mill, that entire production line just grinds to a halt.
So this tiny component can directly halt the global commodity supply.
Without a doubt.
Which brings us to other uses. So these aren't just for sugar. This is a precision filtration technology. Where else is this level of precision so vital?
Well, if you think about it, it applies anytime you need really reliable solid-liquid separation. So chemicals and food processing are obvious.
Right.
But think about pharmaceuticals. That 0.04 millimeter screen is what ensures the purity when they separate out active ingredients. It prevents contamination. It's also used in some niche biotech for things like dewatering algae to harvest biomass.
So what's the big takeaway here? It seems to me that the consistent quality, that fit-ready supply, it's not just about good manufacturing. It's the absolute linchpin for keeping these global industries running at full capacity.
Exactly, and that raises a final interesting question for you to think about. Given that these screens, with slots thinner than a human hair, have to perfectly match complex machines from rival OEMs in Germany, the US, the UK, and China, how much does this single, tiny, hyper-customized component actually dictate the speed and efficiency of commodity production on a global scale?